Okay, this video shows you how to do probability distributions using Excel. And we're going to start with this example. We're going to do a discrete probability distribution. And we're going to do this example. And what this example again is how many radios are sold over, and I think these aren't days, these are weeks. So they're looking at historical information and they're determining out of the last 100 weeks how many weeks did we sell 0 radios, 1, 2, 3, 4, 5. So here's the data in a spreadsheet form. Over the last 100 weeks, the frequency, the count, where we sold 0 was 3. The amount of times that we sold 1 was 20 times 2. And you can see that I can't sell 2.5 radios. So because these are whole numbers, this is a discrete probability distribution. These are the frequencies. So the first thing we're going to do is calculate the probability. The probability is just a relative frequency, which we did in Chapter 2. So we get this, we take this, and we divide by the sum of all of these, which happens to be 100. But let's go ahead and follow the rules and just use it. And you can show it as a probability, as a number between 0 and 1. Or you can show it as probably shouldn't show it as a percent. We'll just leave it as a probability. But they do sum to 1. And that exhausts everything. So this is every possibility of radios sold. This is the probability of selling either 0 or 5 is 100%. Okay. That's the probability. Now let's calculate something called the cumulative probability. The cumulative probability is the probability of selling this or less. So the probability of selling 1 or less, so 0 or 1, would be adding these two up. The probability of selling 4 or less, probability of my random variable is less than or equal to 4, so this, it would be this probability plus this plus this plus this plus this. So that's called the cumulative probability. So an easy way to do this in Excel is that you bring the first one over, and then after that you take the number above it plus the number to the left. So if you've already calculated your probabilities, you can get your cumulative by taking the number above it, the cumulative above it, plus the number to the left. So you can see the probability of selling exactly 3 radios is 20% or 0.2. The cumulative probability, or the probability of selling 3 radios or less, is 93%. So 93% of the time, you're not going to sell, you're going to sell 3 radios or less. Or only 7% of the time are you going to sell more than 3 radios. Okay, that's probabilities. This is a probability distribution, what we've just done. You could certainly plot this if you wanted to. Build a graph of it like that. I don't like that one. Let's go ahead and grab it, but then I don't need the blues there. So that's a probability chart, a bar chart of the probabilities. You could certainly do and include to that you could do the cumulative if you wanted. Don't really need to, but you could. And usually if you do that, I like to see it as maybe as a line chart. That's the cumulative probability. Okay, now let's move on and calculate the mean and the variance. So the formula for calculating the mean is that we've got to calculate for every outcome, we take the number sold multiplied times the probability. So the number sold times the probability, and we do this for every outcome, all 5. And if I add those up, that becomes the mean. This is the expected value, or the mean, or the average. It's how many radios I expect to sell in a week. I expect to sell about 2 radios a week. Now there's variability around that because I don't always sell 2. That happens a lot, but it's not a constant. So we can also calculate the standard deviation, the variance and standard deviation. So how we calculate a variance is we take the difference between this one and this one we square it, and then we multiply by the probability. So you got to use some parentheses, and I take this minus this, and we square it. Now I'm going to copy this down, so I'm going to put dollar signs around my average, and then this gets multiplied by the probability. And if I sum that up, this is the variance. And if I take the square root of that, that's the standard deviation. Standard deviation and variance are always related. You know one, you know the other. The variance, the standard deviation square root of that, or if I take that and square it, that's what I would get. Okay. Now let's move on to example 5.8 in the binomial distribution. Remember what the binomial distribution is. The binomial distribution is based on, if we had one trial, we only would have two outcomes. It's either this or this. There are only a success or a failure, or 0 or 1, this or this, only two outcomes. And we string those together to become a binomial experiment. So we have a bunch of identical trials where each trial has a yes or no, or two outcomes, but we string them together. And they're independent. It's like shooting a free throw. So the probability of making a free throw might be 70%. What's the chances I would make 7 free throws in a row if the probability of one is 70%? It's those type of questions that we answered with the binomial distribution. So let's look at a problem. And in this case, what we have is that we have a new drug that is an antibiotic. And what they're claiming is that 10% of the time, at most, people get sick when they take it. So some medicine, you get sick when you take it. So they're saying at most 10%. So they ran a little experiment, and they tested 4 people, and they determined if did they get sick or not. So you're either sick or you're not. So this is a binomial experiment where the number of trials is 4 and the probability of being sick is 10%. So if we had 4 people take it, what are the chances that 0 people would get sick, exactly 1 people get sick, 2 people, 3 people, or 4 people? And then we can also calculate the cumulative probability, just like what we did above. Now, how do we calculate a probability, a binomial distribution probability? Well, this is the formula we should use, but that's a mess. So let's show you how to do this easy in Excel. You put in the BinomialDist, and the first argument is the number of successes, which is this, exactly 0. How many trials? In this case, it's always 4, and the probability of success of, or we're calling success getting sick, is 0.1. Now the last argument we don't want. This is a yes/no variable, and we don't want a cumulative, so we're going to put 0. So look what I've done. This will give me the probability that exactly 0 people get sick, given that I've tested 4 people and the chances of getting sick is 10%, and I want to know exactly 0. So it's pretty high. And I'm going to copy that down for all of these. So the chances that exactly 0 people get sick is 65%. The chances of exactly 1 person getting sick is 29%. The chances that 2 people get sick is exactly 4.8%, or 0.0486. And guess what? If you add all these up, what are they going to sum to? Well, this is every possibility. If I'm testing 4 people, these are the only things that can happen. Sure enough, that sums to 1. So let's determine the cumulative probability. Well, that's easy. We know how to do this. So the probability of exactly 2 people being sick is 0.0486. But the probability that I'm going to have 2 or less get sick is 99%. So I'm pretty sure that I'm not going to have more than 2 people. In fact, you could even back it up and say, I'm going to run this experiment, and there's only a 5% chance that I'm going to have more than one person get sick, because the probability that one or less is about 95%. So that's the binomial distribution, which is also a discrete, but we're able to look at a special case when the outcomes are only two outcomes, getting sick or not. Now, because of that, we've got some simple formulas to calculate the mean. It's just n4 times the probability of success, in this case getting sick. So this is the expected number of people I would get sick out of 4.4 people. The variance is equal to n4 times 0.7, the probability, 0.1, the probability of getting sick, times the probability of not getting sick. That's the variance. And so the standard deviation is just the square root of that. So that's the mean, that's the standard deviation. You could have used these formulas up here to have come up with these same numbers. They would have worked. The other thing that you could have done is that this binom is the last argument, gives us the exact probability, but what if I wanted this number and I just wanted to find it by itself? So probability that the number of sick people is less than or equal to 3. Basically, I want to return that number. I could use the Binomial Dist, put in the number of successes 3, the number of trials 4, probability of getting sick for one person is 0.1, and then the last argument, put in 1. If I do that, that will give me that number. There you go. That's the same as this. So you could get to this cumulative probability two different ways. Okay, that should get you started on Chapter 5, Binomial and Discrete Probability Distributions.